myself Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to discuss about labeling survey. So let's begin our lecture number 4. In today's lecture we are going to discuss our first topic, which is all about computation of RL, and then we will see the examples of computation of RL. So now, without wasting much time, let's start with our topic number 1. So, for computation of RL, there are two methods, in which method 1 is known as the HI method and second is known as rise and fall method. Now, HI method means what? It means height of instrument method, and second is of rise and fall method. Now let's understand the first method, height of instrument method first, right? So here on screen you can see the reduced level of line of collimation is called as height of instrument, that we have already learned in various terms of labeling, right? Now this is the ground condition, right? And if these are the points whose RL I want to find, and these are the points at the interval of 10 meter. It means here the chainage is of 10 meter. It means 0, 10 meter, 20 meter, 30 meter, 40 meter and 50 meter indicate that here the gap between two stations are of 10 meter, which is known as our chainage, right? Now, if I want to find out its RL, it means first of all I am marking it with station's name like A, B, C, D, E, F, and then I will make one reference line first. So here on screen you can see I have drawn one mean sea level or the datum line, right? Now once I draw the mean sea level, then from that I have to mark my benchmark. So here on screen you can see one benchmark, right? So the RL of benchmark I can get from the mean sea level of that area, right? Then after, if I try to set up my instrument, my dumpy level in such a way that I can get the readings. So basically if you remember, first reading is known as the backside, and generally it is taken on the known RL or the benchmark or the changing point, right? So here it is our benchmark. So I am trying to get one reading over there. Here it is known as the BS, right? Now I can calculate the height of instrument for this setup. Here you can see height of instrument is calculated by adding these two. These two means what? The RL of benchmark plus BS, right? That is clearly shown in this figure. So now if I want to identify the RL of station A, B and C for this setup, it means that A, B and C are indicating that middle 2R of IS, last reading is known as the FS. As we know, the intermediate stations are acting as IS and the last station is acting as FS, right? So now for that, if I have to calculate the RL of station A, so here you can see on screen, it is calculated by HI minus IS, right? Now if you remember the relation or the various terms related labeling, then and only then you can identify that how this calculation works, right? Same way for station B, I can say the RL of station B is equal to HI minus IS, and for station C, RL of C is equal to HI minus FS. So this is the way to calculate the RL of stations, right? But you remember that station C is the last point due to curvature of earth or due to the long distance between 2 points, right? So for that I cannot have the visibility for the next point D. So now I have to shift my instrument, the dumpy level. So here you can see I have changed my instrument, right? And whatever first reading you are going to take is known as BS, but it is always on the station point where the last reading is taken for the previous setup, which is known as FS, right? So now point C, it means station C is acting as a change point for me now, right? Now here you can see that for this new instrument setup, the height of instrument is changed, right? So for that, what you have to do for new height of instrument, for new setup, I have to simply add the BS into the RL of C. It means that station which is acting as change point now, right? So this way you can calculate the new HI. Then after the process is same, if the next points are there, then it will be act as IS and FS, and simultaneously if I have to calculate the RL of station D, it means HI minus IS, RL of station E, it means HI minus IS, and lastly RL of station F, it means HI minus FS. So this is the method which we are going to use for height of instrument method, because if you can see over here, we are taking readings with respect to height of instrument, right? Because in every equation, height of instrument is playing a role, right? For that, every setup we have to calculate its own height of instrument, and height of instrument is nothing but simply BS plus the known RL of the previous station or the change point or the benchmark, right? So this is the procedure for height of instrument method. Now let's understand the second method, which is a rise and fall method. So now for this method, I can say the height of instrument is not at all calculated, but the difference of level between consecutive points is found by comparing staff reading on the 2 points for the same setup, right? So here you can see it is the ground condition and these are 2 points, right? So point A and point B. Now I am setting my instrument in such a way so that if I am taking reading for station A, that is known as the BS, right? Or we can say the value of this first reading is 1 meter. Now if I am going to take reading for station B, then say for the example it is the reading of 0.5 meter. Here you can see clearly on screen that station A is lower than the station B. But now if I want to compare it in terms of rise and fall, then what I have to do? For that, if the forward staff reading is smaller than the immediately preceding staff reading, then it indicates that it is a rise over there. It means station B is higher than the station A, right? So here I can calculate like this. Rise is equal to 1 minus 0.5. It means 0.5 is the difference between these 2 points. Here the rise is always added to the RL of preceding point to get the RL of the forward point, right? That is the concept for rise and fall method. Now assume here the RL of point A is 100 meter. So if I want to calculate the RL of station B, so here as I said I have to simply add it, right? So I will get the answer as 100.5 meter. So this is the way or the procedure through which we can compare 2 points as well as we can calculate the RL of next point, right? For rise we have to simply add it. Now if I talk about the second condition, so here on screen you can see this is the ground condition and these two are the points station A and station B. Again I have arranged my dumpy level in such a way for calculating the RL of these 2 points. So here if I take the reading for station A, it is something like 0.5 meter, and if I am going to take reading for station B, it is something like of 2 meter. So now I can say that if the forward staff reading is larger than the immediate preceding staff reading, then it indicates that it is a fall. Here clearly you can see the fall is there, right? Now for calculation you can see over here fall is equal to 0.5 minus 2. It means minus 1.5 meter. Generally height is not in negative terms, but the negative sign is indicate that there is a fall, right? If it is in positive sign, then it indicates the rise is there, right? So that is the concept over here. Now you can see the fall is subtracted from the RL preceding point to get the RL of the forward point. So here assume the RL of station A is 100 meter. It means RL of station B is equal to RL of A minus fall. It means we gave the value 98.5 meter. So here you can see this is the RL of station B, which is lower than the station A, right? Now let's understand the examples which are used to calculate the RL, right? So let's see our first example. Here the data is given in such a way which says the following consecutive readings were taken with a dumpy level along a chain line at a common interval of 5 meter. It means we are going to set our staff or our station at an interval of 5 meters, right? The position of instrument was changed after 3rd, 7th and 10th readings. It means we are going to change the position of instrument as it is required on field, right, to cover all the points. Draw the form of label book and enter the readings properly. Here we have to prepare one label book, right, for the better calculations. And assume the RL of first point as 50 meter. It means here the benchmark is given as a 50 meter for point 1, right? Here it says calculate the RL of all the points and apply the usual checks. It means after completion of calculation we have to check that whether these all are correct or not, right? Use HI method as well as rise and fall method. It means for this data we have to do calculation with respect to both the methods, right? So now let's understand which are the readings first that are carried out on the field and given in this example. So here you can see the list of readings are there. Now these readings are nothing but simply the BS, IS and FS, right? Now if I want to identify this, what is BS, what is IS and what is FS, first you have to recall BS is something that on particular setup your first reading is known as the BS. On that particular setup the last reading is always known as the FS, and whatever the intermediate points are known as the IS, right? Now the question is how I will know that that is the last reading. Now you can see in given data that clearly says the position of instrument was changed after 3rd, 7th and 10th readings, right? So now please see on screen carefully that how I am arranging the BS, FS and IS, right, according to our given data. So here 0.35, which means our first reading, which means this is my BS, right? Now the final reading is always considered as FS for whole practical, right? Now here I am arranging the third point as FS. Why? Because the statement clearly says that instrument was changed after 3rd. It means after 3rd we are going to change the instrument. It means for this setup 3rd reading is the last reading. It means this is the FS, right? Again after 7th, it means you can calculate over here after 7th reading, it means my 7th reading is of FS, and after 10th it means again it is my FS, right? This is very important. Now once you identify the FS, it means the change point comes in picture. Now you realize whenever you take the FS at particular station, after that you are going to change your instrument. It means whatever the first reading you are going to take is known as the BS but on the same station. It means now after FS I have to simply write the BS as you can see on this screen, right? Now whatever the intermediate points are there, now they all are act as IS. So here these all are the IS for these kind of readings. So this is the concept or the logic to identify the BS, IS and FS, right? Once you identify this BS, IS and FS, then you have to prepare the label book, and after calculation you have to provide the checks. So now let's understand that how the HI method works for this kind of arrangement, right? So here you can see the readings, and now you know what are the BS, IS and FS. Now as I said, I have to prepare one label book. So this is the label book. Here you can see the first column is all about stations. It means where we are going to hold our staff, not the label, right? Second is of chainage. Now you can see here I have write 0, 5, 10, 15 as it is indicated in given data. The chainage is of 5 meter. So 0, 5, 10, 15, right? Now BS, IS and FS. Now this BS, IS and FS column is same for HI method as well as rise and fall method. So you have to understand that putting value of BS, IS and FS correctly is very important, whether it is HI method or rise and fall method, right? After that, here first we are going to use HI method, so that I have write HI, and the overall question is to find the RL of stations. It means we are putting the next column as the RL of different stations, right? And Lastly, I am putting or add one column of remark because sometimes the change point and benchmark play an important role to identify that we are going on correct path or not, right? So that is the format of this label. Now you can see on screen that station A is here, chainage is of 0 meter, and as I said the BS, because you can see the readings are here and you have marked the IS, BS and FS over here. Now I have to put the values over this table. Then you can see 0.35 is the first reading. It means I have write 0.35 over here in station 1. Then this reading is of station 2. It means I am going to write the next reading in the column of IS as I have mentioned over here the IS. It means 0.58. And then after the third reading for third station, it means which is of 0.645. So this is the way BS, IS and FS I have marked, right? Now once the FS comes, it means you are talking about the change point. It means this station is act as a change point. Now whenever the change point comes, it means on the same station the last reading and the first reading comes to connect these two setup, right? So the third reading which is of FS is over here, but after that whatever the reading is known as BS, that is correct, but that we have taken on the same station. That is why I am marking or putting the values in the BS column but in the station number 3 only. That is very important, right? So please keep in mind that whenever I write change point, FS and BS values fall into the station 3. It means on the same station, right? Now once you put the value of BS, it means you have to identify how many IS are there. So there are 2 IS. It means 2 IS in next 2 stations are there. Then after the FS, it means the value we are going to put in the FS for next station. Whenever you put the value for FS, at that time you have to indicate this is your change point 2. Whenever the change point come, it means you have to put the next value, which is again the first value for the next setup, which is act as BS but on the same station. Here the station is 6th one, right? So you have put the value as 0.36. Now here you can see after that there is one IS. It means 0.72, and then again it is an FS which is of 1.2. It means whenever the FS comes, it means the change point come. Here it is our change point 3. Now whenever the change point comes, we have to put the value of PS on the same station over here. So I have put the value 0.92 on the same station, station number 8, right? Now you can see over here after 1.2 there is the next BS, that is 0.92, and last reading is of 0.63. It means there is no intermediate station. So there is no need to write in IS section. You have to simply write in the FS, right? So you have put the value 0.63 in the FS column. This is very important to fill the correct value of PS, IS and FS for all these stations, right? Once you put all the value correctly, then only we can start for the HI method calculation, right? So now once we put all the value, the first task is to identify HI, right? Because as you know that in HI method we have to calculate RL with respect to height of instrument. Now here, how can I calculate the height of instrument? Now if you remember the various terms in which we have discussed, height of instrument can be calculated by simply adding the BS into the known RL or benchmark or change point, right? Here in the first case we have the benchmark which is given in the example, which is marked as the known RL of first point. For the first station we have the value of RL as 50, so I have written in the RL column that is 50 meter and I have remarked it as a benchmark, right? So 50 plus 0.35 which gives me the height of instrument, which is of 50.35, right? Okay, now once you know the height of instrument, that height of instrument is used to carry out RL of different points when we are talking about the particular station. Once you know the height of instrument, then and only then you can calculate the RL of all the points. So now for station 2, if I want to calculate the RL of station 2, I simply have to do what? HI minus IS. As for station 2, the IS value is given, right? So 50.35 minus 0.58 will give me the RL of station 2. Same way for station 3, if I want to know the RL of station 3, it means HI minus FS. Now, the FS words indicate that this setup or this reading is the last reading for this particular setup. It means the answer, whatever I get from 50.35 minus 0.645 is RL of next point, which is of station 3. But now this is the end of this setup. It means this is my change point. Whenever the change point come, I have to calculate the new HI. So here you can see I have calculated my new HI. Now for this, the known RL, which is recently we have identified the known RL for this point plus the BS, which is 1.85, which will give me the value of HI, which is of 51.555, right? Now, once you know the HI, it means simply you have to minus the IS and FS to get the consecutive RL, right? So 51.555 minus 1.935 will give me the next RL 49.62. Same way, 51.555 minus 2.45 will give me the answer of RL of station 5, which is of 49.105. Same way, 51.555 minus 1.75 will give me the answer 49.805 for this station 6. Now again, when I come to the FS, it is indicating me about change point. And whenever the change point is there, I have to calculate the height of instrument. So here, the height of instrument, I have to calculate by simply adding 0.36 into the 49.805 that we have just identified, right? That is the RL of that particular station. So we will get the value of HI as 50.165. Now when you know the height of instrument, you have to simply minus it. It means if it is an IS and if it is an FS, you have to simply minus it. 50.165 minus 0.72, which will give you the answer of next station's RL, which is of 49.445. Here you can see, if it is the FS, you have to simply minus it again. So it means 50.165 minus 1.2 will give you the answer as 48.965, right? So it is indicating this is my change point 3. So now whenever the change point 3 comes in picture, you have to identify the new HI. It means here I have to simply add my PS 0.92 to the identified RL. It means 48.965, which will give me the answer of HI. Now here only FS is there. There is no IS. It means for RL of last point, I have to simply minus my FS from my new HI. It means 49.885 minus 0.63, which will give me the answer of last point's RL as 49.255. So now you better understand the equations or the logic behind calculating different HI and respective RL of different points, right? So this is the method through which we can identify the RL of different point using the height of instrument. Now here in the end you have seen that summation of BS and summation of FS, it means the overall summation for this column and this column is generated. These are generated to do the checks. Now what are the checks? For check, there is one equation which says summation of BS minus summation of FS is equal to last RL minus first RL. It means when we put all the values in this equation, the answer should be equal. Then and only then we can justify that these all calculations are correct. So this is all about HI method, right? Now let's understand the second method, rise and fall method, for the same example. So now first the readings are there. Now you know the BS, IS and FS arrangement and the table is there. It means here the station, chainage, BS, IS and FS are same as it is as in HI method. But the change is only that here in spite of HI we are adding two columns, rise and fall. Then after we are finding the RL. So RL and lastly we are adding the remarks, right? Now I have to do calculation for rise and fall method. Now if you remember, rise means what? Whenever you are comparing two stations value, if the difference is positive, it means it is indicating there is a rise. And if the difference is negative, it indicates there is a fall. Now here you can see in this table for station 1, the value is 0.35. For station 2, the value is 0.58. It means from 1 to 2, I am going to minus it, or I am taking the difference of these two, which says 2 is above or below with respect to 0.1. It means here we are taking 0.1 as our reference point. Here always come a dash because it is our reference point. It means from BS minus IS, whatever the value we get, if it is of minus, I will put it in the column of fall. Again, if I do the IS minus FS, it means comparison of these two, whatever the value plus or minus, here it is again a minus because 0.5 minus 0.6 will give me the value as 0.065. Again, it is a fall. Whenever the Fs comes, as I said, it indicates it is a change point. It means I have to start from BS now because the instrument setup is changed. So now what I have to do? Simple, BS minus IS, right? So BS minus IS will give me again a fall value. So I put it over here. Again, IS minus IS, whatever the value, negative value. So I am getting my fall. Again, IS minus FS, which will a positive value, as you can see over here, 2.45 minus 1.75, which is of 0.7. So it is a rise. Whenever the FS comes, it means this is the change point. It is indicating I have to stop here, and for my next setup, I have to do BS minus IS or IS minus FS, right? Now, it is indicating that it is a change point 3. I have to stop over here and simply BS minus FS we will do over here as there is no IS available. So BS minus FS will give me the answer, positive answer, which is of 0.29. So I will put that value in the rise column, right? So this is the way I am putting the value of rise and fall according to the BS, IS and FS. Now once you identify all the rise and fall columns, then what you have to do? You have known the first value, which is your benchmark as 50 meter. Now as I said, I have to simply do what? 50 minus 0.23 because fall indicate minus, right? So if I want to know the RL of next point, if it is a fall, I have to simply deduct it. So 50 minus 0.23 will give me 49.77. 49.77 minus 0.065 will give me the 49.705. 49.705 minus 0.085 will give me 49.62. Same way 49.105, but now it is a rise. It means 49.105 plus 0.7 will give me 49.805. Now you understand, if there is a rise, I have to simply add it. If there is a fall, I have to simply minus it. So again, there are two falls, so I am going to minus it, right? So this is the way of calculation for RL of different points for rise and fall method. Now in this table you can see over here that summation of BS and summation of FS are there, but now the two thing is added, that summation of rise and summation of fall is also calculated. Because when we go for the check equation, at that time the equation says that summation of BS minus FS is equal to summation of rise minus fall is equal to last RL minus first RL. Again you can see over here that all differences are having same value, which indicates that these calculations are correct. So this is the same example with the second method, rise and fall method, right? I hope you understand both the methods very clearly. Now let's discuss the second example, right? In second example, the data is given in such a way which says the following consecutive readings were taken with a dumpy level and 4-meter leveling staff on a continuous sloping ground at 30-meter common interval is given. Now here one thing is added, 4-meter leveling staff. Now what is the leveling staff? Leveling staff is something on which we are taking the readings and it is of 4 meter. So this is the information, right? That is not required for calculation. This is the additional information is given to misguide you, right? Here the interval is of 30 meter. So don't misunderstood between 4 meter and 30 meter. Now what further it says, draw the form of level book and enter the readings properly, right? Assume the RL of first point as 80.75 meter. Calculate RL of all the points by rise and fall method and apply the necessary checks. That is okay. Again, one line is added that also find gradient of a line joining first and last point. Now here you can see one thing is added that we have to find the gradients, right? And one thing is missing. What is missing? Here there is no indication for change point. So how you can identify your BS, IS and FS, right? So first let us understand the readings. So here you can see on screen that readings are there. Here readings are gradually increasing initially but then suddenly decreases after 6th and 10th reading. That indicates that instrument work should shifted after 6th and 10th reading. It means here you can see that first and last reading is BS and FS. But now I have marked, if I take the difference then I can know that 6th and 10th reading. Here you can see that 2.885 to 3.38, it is a variation, right? Again 2.265 to 3.54, it is a great variation. Whenever you check the comparison for the difference, then and only then you can identify that whether the difference is increased or decreased, and that sudden increase or decrease point indicate that there is a change point, right? It means other points I have to consider in such a way that after FS it is always an BS, and after that whatever the remaining points are my IS. It means the intermediate points. So this is the way or the perfect method if the data is not given regarding the change point, right? It is very important to identify if it is not given, because as we know now that without BS, IS and FS indication, we cannot apply any of these two methods, right? Here we have to use rise and fall method. So now let us draw the table for rise and fall method. Here you can see the station, chainage, BS, IS and FS. Again it is a rise and fall method, so rise and fall. Then after RL and remand. Here you have seen that chainage of 30 meter. That is why I have written in chainage 0, 30, 60, 90, 120, 150 till my all points are covered. Now here on screen you can see this is the first BS. That is why I have written over here in BS 0.68. Then there are 4 IS. It means I have written 4 IS. Then after I have written the FS. It means this is my FS. Whenever the FS comes, I have to write in remark change point 1. Whenever the change point comes, I have to write the next reading as a BS in the same station, right? Now this is my next setup, that after BS, whatever the IS, here 2 IS are there, so 2 IS are there. Then after whatever the FS, it means 3.54, which indicates it is my change point 2, right? Whenever the change point comes, I have to go for the BS on the same station, right? So that is why 0.835 on station 9. Then after here you can see 2 IS are there, so the 2 IS values are there, and lastly the FS value is over there, right? So with respect to first point, 0.68 minus 1.455, which is a fall, right? So I am getting a minus value, so I put this value in the fall column. Likewise 1.455 minus 1.85, whatever the value is, again minus, so fall. 1.8 minus 2.3, 2.3 minus 2.8, it means again these all are the fall, and here you can see 2.88 minus 3.38, again it is a fall. Now whenever the FS comes, the change point comes, I have to stop here and start from the BS. So BS minus IS, IS minus IS, IS minus FS. Whenever the FS comes, I have to stop and start from BS minus IS, IS minus IS and IS minus FS. Now it is also clearly seen in this table that all the values are in fall, and in given data again it is said that it is continuously on sloping ground, right? So here you can see a sloping ground is all of fall, so that is why I get all my values in this fall. Now if I want to calculate the RL, so now you know the first points, first stations benchmark, which is already given in the example, which is of 80.75. So whenever you have the value of RL, you have to simply minus the fall to get the next RL. You have to simply minus 0.4 to get the next RL. Likewise, you have to proceed for all the points. So that's why you get your last points RL by following this method. So after getting all the RLs for all the points, you have to do the equation of check. For that, first you have to calculate the summation of BS, summation of FS, summation of rise and fall. Because in check's equation, it says that summation of BS minus FS is equal to rise minus fall is equal to last RL minus first RL. Here you can see the values are same. It means the calculations are okay. But if you remember, there is one last line added which asks for gradient. So now the falling gradient over here I can calculate by simply getting the difference of RL of last point and the first point upon the difference of horizontal distance. So here I get the answer as 1 by 50, which says the slope of 1 gem 50 is present at that field or the ground condition, right? So this is the way we can calculate the gradients. So this is all about the examples of computation of RL. So in today's lecture, we have learned two important and basic terms, which is HI method and rise and fall method, and relatively their examples. I hope you understand all these topics.